I'm Rufus Griscom, and this is The Next Big Idea. Today, human life expectancy doubled in the last century. Can we do it again in the next 100 years?
On the 10th of December of 1954, I was the volunteer human subject for an experiment in which I rode a rocket sled from a standing start to 632 miles an hour in 2,800 feet. I came to a complete stop in 1 4/10 seconds.
That's Colonel John Stapp, a man who looks as unassuming as he sounds. Big forehead, horn-rimmed glasses, chubby cheeks. About the last guy you'd expect to hold the title of fastest man on Earth, a title he claimed on the 10th of December, 1954, on a strip of railroad track sliced through barren desert in New Mexico. Mounted on that track was a makeshift contraption called Sonic Wind 1. It looked like a parade float with a lone chair made out of metal pipes, and instead of crepe streamers billowing off the back, there were 9 rockets. They gave the Sonic Wind its other name, Rocket Sled. Stapp, who had both an MD and a PhD, had been riding these jet-powered death traps for years. It was part of his quest to solve what he considered to be the most vexing question posed by his era's technological advancements. What happens to a human body when it goes from 100 miles an hour to a dead halt in a matter of seconds? This question, Stapp realized, was quite literally a matter of life and death. At the time, the military believed it was impossible to survive more than 18 Gs. But Stapp set out to prove them wrong. If he could, he'd prove that a pilot could eject from a supersonic flight and live. That day, in December 1954, Stapp took his lonely seat aboard the rocket sled. Nervous attendants used 4 nylon belts to strap him down. They shoved a white helmet over his head and stuck an accelerometer in his mouth. Then they took cover in a nearby hut where one of them started the countdown.
4, 3, 2, 1, fire!
The rockets detonated, spitting out 35-foot flames and blasting the sled down the track. It reached 632 miles per hour within seconds. Then it came to a juddering stop in just 1.4 seconds. Attendants ran over to the sled. On previous slower tests, Stapp had cracked ribs, broken his wrists, and lost fillings in his teeth. This time, he said, as attendants helped him onto a stretcher, I get the white cane and the seeing eye dog. His eyes were full of blood. Every capillary had burst. His luck, it seemed, had finally run out. But miraculously, his sight returned within a day, and he was otherwise unscathed. By enduring a G-load far greater than what the military thought was survivable, Stapp had proved that you could, in fact, eject from a supersonic plane and live to tell the tale. But that wasn't all. He soon came to realize that his experiment had other implications.
The fact that a properly shock-mounted human body, seated in the forward-facing position, can sustain 4 tons of force applied within a quarter of a second and suffer no disability is just as significant for automobiles as it is for airplanes.
If you could go from 632 miles an hour to 0 in 1.4 seconds and walk away, what about going from 60 to 0? And so that spring, Stapp invited auto industry execs to come to the test site in New Mexico and discuss ways his findings could be used to make cars safer. Because cars at that time were more dangerous than rocket sleds. Consider the Chevy Bel Air, the best-selling family car of its day. It didn't have headrests or rearview mirrors, and it definitely didn't have airbags, crumple zones, or 3-point seatbelts, because they hadn't been invented yet. It's no wonder that auto fatalities per capita were nearly twice what they are today. And car makers weren't exactly racing to make their vehicles safer. They argued there was nothing they could do to counteract simple physics. The human body, they said, was not meant to withstand car crashes. And so that spring, when they gathered in the New Mexico desert, Stapp helped reveal the error in their thinking. They came back the next year and the next. Today, the Stapp Car Crash Conference brings together the top safety experts in the auto industry, and the innovations they've initiated, innovations inspired by Stapp's discovery that a properly shock-mounted human body can withstand a whole hell of a lot, have helped save millions of lives. Colonel John Stapp is one of the many unsung heroes who's helped us in the last century live longer lives. These unsung heroes are at the center of a wonderful new book and PBS series by my guest today, the acclaimed science writer, Steven Johnson. Both the show and the book are based on a single remarkable fact. If you were born 100 years ago, you could expect to live to be 32. Today, life expectancy is more than twice that. Steven manages to take that statistic and turn it into a riveting historical narrative. He shows how this fantastic human achievement wasn't just due to scientific breakthroughs like antibiotics and the AIDS cocktail, though they certainly helped. We've extended our lives using tools you might not expect: sewage systems, pasteurization, chlorinated water, and of course, seatbelts. Over the last century, we've made great strides in our search for immortality, and we're not slowing down. Today, breakthroughs like CRISPR gene editing promise to cure hereditary diseases. Artificial intelligence has emerged as one of the most powerful new tools we have when it comes to drug discovery. Self-driving cars could reduce traffic fatalities even more than the seatbelts, airbags, and the other safety mechanisms that Stapp helped inspire. I called Steven at his home in Belvedere, California, to discuss both the extraordinary accomplishments of the last century and the promise of what's to come.
Hi, I'm Kwame Christian, CEO of the American Negotiation Institute, and I have a quick question for you. When was the last time you had a difficult conversation? These conversations happen all the time, and that's exactly why you should listen to Negotiate Anything, the #1 negotiation podcast in the world. We produce episodes every single day to help you lead, persuade, and resolve conflicts both at work and at home. So level up your negotiation skills by making Negotiate Anything part of your daily routine.
Steven Johnson, welcome back to the Next Big Idea podcast.
Thanks, Rufus. It's great to be back.
You know, Steven, my whole life plan has been to have conversations with friends for a living. So I feel like it's all coming together here.
I think you've laid it out brilliantly, and here we are.
Well, Steven, I've had the great pleasure of watching you write and publish a dozen books over the last couple decades. Meanwhile, it's not exactly clear to me what I've been doing while you've been writing all these books. I mean, I've had 3 sons, no small accomplishment, but you've also had 3 sons.
I don't think we need to turn this into a competition. I mean, I feel like you've done a lot as well. If we want to talk about your achievements, I'm happy to do that.
Okay, I have built a few media companies. All right. But in any event, I've noted watching admiringly your book writing process that the timing of the release of books is something that really matters. And I think it's something that's lost on a lot of readers and maybe listeners. I remember your book, Wonderland, one of my favorites, How Play Made the Modern World, was released in November 2016, just after Trump was elected. Not ideal timing.
Yeah, it was a book about the importance of delight and the playful mindset in driving progress in the world. And I think there just were not a lot of people who were in the demo for reading that book who were in the mood for that kind of book right after the election results. So yeah, it's something you just can't control when books come into the world.
But you've been repaid by the cosmos because your latest book, Extra Life, A Short History of Living Longer, that you thought, I think, when you were writing it, it could be timed with the 100-year anniversary of the Spanish flu. You had no idea the world would be hit by a massive global coronavirus epidemic while you were writing this book. Is that right?
Yeah, I mean, the idea for the book is, 4 years old, I think. And I wrote it, most of the book was written before COVID, but we'd always had this idea that maybe there would be a television series that could accompany it. And as I was writing the book, we were working on trying to get the show made. And the show was almost not made. It took a long time to get it together. And then in the early months of 2020, as this new rogue novel coronavirus began to circulate around the globe, we realized that we were kind of sitting on this story about the history of public health and medicine and vaccines. And it suddenly had this newfound relevance to everything that was happening. The book was going to happen no matter what, but it was COVID that got the BBC series made. And we ended up making the show, in a sense, as a story of both this history of life expectancy and kind of a real-time look at the present.
Well, none of us wanted a global coronavirus epidemic, but it is nice when the historical moment cooperates with the release of your book, and it's incredibly timely, incredibly interesting. And on the subject of historical affirmation, I think Barack Obama gave Extra Life some love recently, tweeting that it, quote, offers a useful reminder of the role of modern medicine in fundamentally transforming all of our lives. And as you point out, it is in these moments that we all become aware of this whole journey we're on collectively to try to improve public health.
Yeah, the spirit of this whole project was that we do not recognize how much we are the beneficiaries of this kind of progress in human health. And we don't recognize it for a couple of reasons. One is that it happens slowly and incrementally over time. It's not a sudden kind of dramatic breakthrough. And the other reason I think people tend to discount it is that the progress, in a weird way, is measured in non-events, right? It's measured in the things that didn't happen to you. You didn't die of smallpox when you were 5 because smallpox was eliminated. You didn't die in that car crash you were in when you were 15 because seatbelts had been invented. And so there's a weird blind spot that we have to these kinds of amazing triumphs. And to me, the best way to kind of trick people into really recognizing the magnitude of the change that we've undergone as a species, I mean, this is a global story, is through this one measurement of life expectancy. That is just, to me, the condensing down of all of these extraordinary advances into kind of one number. In a sense, the book and the show is the story of this one number that really measures probably the most important form of progress there is.
Well, it's a gripping story, both the book and the television show. And I'm so excited to be talking about it with you today. And as a special treat for our listeners, we're going to spend the last part of our conversation on what's coming next on the new technologies, going even beyond what's in the book and the TV show. Let's jump right in and take a listen to your first big idea.
We doubled human life expectancy over the past century. If you rewound the clock 100 years, the average human life expectancy was somewhere in the mid-30s. In the United States, during the last great pandemic, it was 41. Today, global life expectancy is 72 years. In some parts of the world, it's approaching 90. We've basically given ourselves an entire extra life in just a century. A significant amount of that change came from reductions in childhood mortality. I mean, until very recently, more than a third of all children died before reaching adulthood. It didn't matter whether you were rich or poor, whether you were living in a metropolitan city or you were a hunter-gatherer. 2 out of 5 of your children would die before reaching adulthood. And now, childhood has become the safest time of your life. But we're also extending life at the other end of the spectrum. In England, where we have the best data on these things, if you made it through childhood in 1850, you could expect to live another 40 years to the age of 60. Today, a British person who survives to the age of 20 can expect to live into their late 80s. Globally, the percentage of people living over 100 has quadrupled in the past 2 decades. I think this is the single most important thing that has happened to us over that period. If you had a newspaper that came out once a century, the doubling of human life would be the banner headline.
This is extraordinary. I mean, it's so easy to forget what a perilous world it was for children in particular, and for everyone really, before about 100 years ago. I mean, not only were doctors ineffective for most of human history, but they were actually counterproductive, right? I mean, even though the Hippocratic Oath, first do no harm, dates back to the Greeks, harm is precisely what a lot of the doctors were doing before, I don't know, about 100 years ago. Is that right?
Yeah, that's one of the things that was most surprising to me in researching the book, which was how late, in a sense, medicine is as a useful intervention. It doesn't really start to have a positive effect other than vaccines until the 20th century. And there are some fascinating studies that came out recently where people looked through kind of mortality records from the 1600s, 1700s. And they actually found this strange thing where the wealthiest members of society were actually dying a little bit earlier than the working class members of society. And the theory is that that was because the wealthier members of society had access to doctors. And so everybody else was just kind of getting, cured on their own through their own immune reactions to things. But the wealthy people were like going to the doctors, and the doctors were like, you should have some arsenic, or let me attach these leeches to your body. and so it just was really useless or, actually harmful for an incredibly long period of time. And the other thing that I think is so, I don't know, just powerful in thinking about this is just how terrifyingly dangerous childhood was. That now childhood, once you survive for kind of 6 months, the period from 6 months, to when you're about 30 is the safest point of your life. You are the lowest risk of dying in that period. And it was exactly the opposite until really the 20th century and till the late 20th century in many parts of the world. The most dangerous time to be alive, was when you were a year or 5 years or 10 years until you got to be very, very old. And think about what that means as a parent. You just read any 19th century novel and the children are just dying constantly. And it was just a reality of life that a third of your children would die. That was the standard. That was the default. And the fact that we've changed that in such a short amount of time is really just remarkable.
It's just unthinkable to us today. So if any of our listeners encounters a time machine, what's the date before which you should just run away from doctors as fast as you can? Like what was the inflection point when the medical establishment actually started meaningfully improving people's outcomes?
So if you do have a time machine, it's both time and place, right? It's where you're going and when you're going. But two big things is that hospitals were just very unsanitary before the germ theory of disease was developed, and Semmelweis finally convinced people to wash their hands, between surgeries, which was a breakthrough that really became the norm in 1870. So you could go in and have an operation and not, risk dying of infection starting in 1870, 1880. But the real medical advances that came from, pharmaceutical drugs, that really didn't start in earnest until the 1930s and 1940s.
Which is astounding because if we think back, we had, obviously trains, but also electricity, photographs, early television, radio.
Right, yeah.
Right? I mean, we think of this as a technologically sophisticated time. And this coincides, I think, right, with the advent of the first randomized controlled trials, the first RCTs, right? I mean, a lot of this was just about being disciplined about executing the science of figuring out what was and wasn't working.
Well, it's a very interesting paradox in a sense of why medical drugs took so long to be invented. And as you say, because we didn't have randomized controlled trials to test the efficacy of a given drug versus another drug, right? That's what we've been living through with the vaccines and COVID, right? We have these systems to figure out, does it work? We had to invent those systems. It was not an intuitive thing to figure out if a drug would work or not. You would think that there would be market forces that would select the good drugs versus the bad drugs. But medicine is a weird thing because of two things. One, we have a built-in immune system that, often is able to fight off, an infection or an invading virus. And there is an interesting quirk of nature, which is the placebo effect, where when we're given drugs and told that they're effective, we will 20% of the time actually get better, even if they're not effective. There's something about the psychosomatics of it that work in that way. And so the marketplace for drugs is skewed a little bit by the sense that if somebody sells you a sugar pill, like it will actually work a lot of the times, but not because of the reason you think it works. It works because your immune system works. It works because the placebo effect works. And so we needed RCTs, these kind of statistical experiments, to be able to tell like what was really working, to understand like what was a really useful intervention to make. And that just arrived late. It didn't arrive until the late 1940s.
Getting to the nuts and bolts of how we doubled the human lifespan in the last century, which your book does beautifully. There's this extraordinary chart early in the book that I just loved, I kept returning to, that breaks out the innovations that have saved millions, hundreds of millions, and billions of lives in the last 100 years. So in the millions column, we have things like seatbelts, pacemakers, the AIDS cocktail. In the hundreds of millions of column, we have antibiotics, blood transfusions, the pasteurization of milk. In the billions of lives saved column, we have fertilizer, the sewage system, and vaccines. Why don't we start with vaccines? As much as I love fertilizer, we've all been thinking a lot about vaccines lately. How does that story unfold?
Well, it's one of the earliest. It's the opening kind of chapter in the book. It was the first episode of the show because it really is one of the first major breakthroughs that starts to make a difference. The smallpox vaccine was developed in the late 1700s. There was a kind of technique that predates it called variolation that is ancient, actually, and was developed outside of the West and kind of migrated into the West through this fascinating woman, Mary Montagu, who brought it to England from Turkey. But it was, it was the first time where there was this preventative effort of, deliberately infecting someone with some attenuated version of the virus in question, in this case, smallpox, or a related virus, which is cowpox, which is what the original smallpox vaccine used, that would then trigger an immune response and give the vaccinated person immunity, in the case of smallpox, generally for life. And this was an extraordinary breakthrough, in large part because smallpox was just maybe the greatest killer in human history. I mean, it dates back to the Egyptian pharaohs and killed a staggering amount of the both rich and the poor in the 16th, 17th, 18th centuries. The number of European royalty who died of smallpox during that period is just unbelievable. Far bigger impact on geopolitical events than any would-be assassins or military campaigns, was just this virus killing one world leader after another. So being able to actually intervene in advance of someone getting sick and to give them a kind of artificial immunity was just an incredible leap forward.
I mean, just to think of the degree of the blight on humanity that smallpox was, I think it's hard for us to fully comprehend that. I think it killed 3 out of 10 people over thousands and thousands of years. And the instinct with the early variolation to go in, who was this young Dr. Jenner, and scrape the pus from the pustule of a cow pox.
Yeah.
And put it into the arm of a boy. And this was the beginning, right, of what would be a sustained process of figuring out how to protect people from this horrible disease.
Yeah, and it eventually culminates in the eradication of smallpox in the 70s, a project that began really in the kind of mid-60s, took about 10 years to do, and I think is really one of the most impressive things that we have ever done as a species. And the argument that I've been making, in the age of COVID is that if we celebrated the eradication of smallpox the way we celebrate something like the moon landing, which happened in the same time frame, we would have a lot less vaccine hesitancy right now. We'd recognize wow, vaccines did this incredible thing. They eradicated, this ancient killer for good. That's what science does. That's what vaccines do. I think we would appreciate the importance of vaccines a lot more than we do. We wouldn't have a lot of the controversy we're in right now.
Well, I know you appreciated your vaccine when you received your first jab, because I heard you describe it on your PBS television show, Extra Life. I think we have the clip. Let's play the clip.
David.
How you doing?
We're connecting online.
I'm good.
David, just by coincidence, I got the first dose of the COVID vaccine just 2 days ago. And as I was sitting there waiting to get the shot, I just found myself thinking of all that ingenuity and knowledge and hard work summed up and jabbed into your arm and giving your body this new protective power that it didn't have before. I think of it as almost like a kind of invisible shield. And vaccines are a big part of it, but the whole infrastructure of public health and medicine that has been quietly extending our lives for the last 2 centuries with increasing success. And the one advantage, if advantage is the right word for it, of a pandemic like the one we're living through is that suddenly that invisible shield is visible. And the need for that suddenly becomes very urgent.
It's funny that in that clip, I'm talking to my co-host, David Olashoga, who's wonderful. A lot of the show is kind of a dialogue between us. And as it happened, David got vaccinated the same day that I did. And we didn't put it in the show because it just seemed too random that we both had gotten vaccinated on the same day. He was in England, I was in New York. But I did feel, I kind of teared up a little bit when I got the vaccine, not because it was painful or anything like that, but because I was genuinely moved by it. And I did, in part because I've been working on this project for so long, I did think about that long sweep of of history that kind of had led up to the development of the COVID vaccines, and what an incredible achievement they were. And the combination of feeling, okay, I am, as of this second now, much safer than I was, and protected against this terrible threat, but also just all the work and ideas and collaboration that went into making vaccines in the first place and making this specific vaccine. And to remind ourselves of kind of the majesty of that, I think is a really important thing to do.
It was extraordinary to listen to Dr. Fauci, who you interview for the television show, express how amazed he was by the speed and capabilities of these new mRNA vaccine technologies. Why don't we play that clip as well? I think that's pretty interesting.
If I would have told my mentors back then that, guess what, you don't even need to get the pathogen in your hands to make a vaccine. So, the old vaccinologists of back in the day, as it were, would have laughed at you. What do you mean? How can you make a vaccine if you don't have the pathogen? Well, all you need is a computer screen. And, the first sequencing of pathogens back not too long ago would take over a year to do. You can do it now essentially in a day. You can just, bingo, you've got it. So in the case of COVID-19, as soon as the Chinese put up on the database, the public database, the gene, we knew in a microsecond that gene codes for the spike protein. So you pull out the gene, the sequence, in silico, in the computer.
It's software.
Yeah, it's there, it's software. You pull it out and you stick it into whatever your vaccine platform is. And the body sees it, makes an antibody response. That's it, you're done. That is just such an extraordinary advance in vaccinology right now. It's completely different than it was years ago.
So we are incredibly lucky that COVID didn't hit a decade or two earlier.
Yeah. It's interesting. When the day we interviewed Fauci was the day the first official efficacy numbers had come back for the Moderna vaccine. And it was showing efficacy of, against serious disease, whatever it was, 94 or something, 94%, whatever. And Fauci was he danced into the studio where we were interviewing him. He was so excited. He was like, you can't, he said in his Fauci voice, he was like, I've gotten a lot of bad breaks in my career, but we got a great break with this one. And it was just so great to see. And yeah, I think the thought experiment is with HIV, it took us 5 years just to identify the virus, just to figure out what was causing this weird disease. And here we are still 40 years later, and we have treatments for it, but we don't have a vaccine. So imagine the COVID crisis where we don't have Zoom, we don't have we don't have the internet, we don't have Amazon, we don't have all these things that enabled us to work remotely. And it takes us years just to identify the pathogen, and takes us, maybe it takes us 5 years to develop the vaccines. That would have been the reality if COVID had happened just, probably 15 years ago.
It's a reminder of just how quickly medical capabilities and science are evolving right now.
Yeah, I think that there's this window of time where we are at increasing risk to these kinds of pandemics because the human footprint on the planet is so much bigger. The sheer number of chickens alive in the world that could potentially be kind of breeding grounds for an avian flu that could be much more deadly than COVID actually, and global air travel and stuff like that. So there's this interesting kind of race that's happening right now where there is this period where we as a species are extremely vulnerable to particularly, respiratory viral infections sweeping around the globe in a way that was harder for, a novel virus to sweep around the globe 200 years ago. People didn't move that quickly. But at the same time, the science is advancing at an amazing clip as well. And so, I think honestly that there's this zone for the next 10 or 20 years where, the science is going to advance, but we're still going to be vulnerable. And I suspect probably beyond that we might be able to create these universal vaccines, a universal influenza vaccine, a universal coronavirus vaccine that will just target all viruses in those families. And we might actually be able to kind of bring the age of pandemics to a close potentially. But until that point, it's kind of neck and neck. And we'll get out of this pandemic at some point, probably from coronavirus becoming endemic and just becoming less deadly. But, there's no reason to suspect we wouldn't face another one of these things in the next decade or two.
Well, let's hope not. But at least hopefully we will have learned from this experience collectively.
Hey you, I'm Andrew Seaman. Do you want a new job? Or do you want to move forward in your career? Well, you should listen to my weekly show called Get Hired with Andrew Seaman. We talk about it all, and it's waiting for you, yes you, wherever you get your podcasts.
Now, you point out, Stephen, that we don't celebrate medical breakthroughs the way we do space exploration or military victories, even though we should. But I would say we're even less aware of public health improvements like the pasteurization of milk, the development of seatbelts, much less toilets, and the sewage system, which brings us to big idea number 2.
Don't just thank the doctors. Toilets and sewers were just as important. We have a natural tendency when we think about improvements in human health to focus on the medical interventions, the pills or the x-ray machines or the vaccines. But sometimes the breakthroughs that make the most difference are the ones that are kind of behind the scenes or don't even look like major technological advances. And one of the great killers of the 19th century was drinking water. In a big city like New York or London, you could drink a glass of water and be dead from a terrible disease like cholera in 48 hours. This was just one of the great killers of the time. And so the improvements we needed to make were not improvements that were happening in hospitals or in doctors' clinics. They were improvements happening in basic infrastructure. We had to figure out a way to clean the drinking water supply of big cities, and that made all the difference. So the invention of a toilet and the sewer system that it's attached to, or systems of water delivery and the chlorination of drinking water, those are momentous achievements in the history of human progress. They aren't quite as sexy as satellite radio or your smartphone, but they actually make more of a difference in overall health and the length of human life.
Well, I'd like to say for the record, Stephen, that I personally do not take indoor plumbing for granted. I think I've taken for granted vaccines and other elements of the invisible shield protecting me throughout my life. But every time I go on a camping trip, I think for the first 2 days, why don't more people spend time in nature? It's so beautiful. And then by day 3, I'm just thinking the invention of plumbing was just an extraordinary achievement.
No, it's absolutely right. That is why I have not gone on a camping trip since 1978, I believe. It's the last time I went on one.
Yeah.
This is a good example of how the role of data is often just as important as the kind of tangible interventions, because, the big breakthrough of the 19th century was this understanding that water was transmitting these diseases like cholera, and that there was some invisible agent in the water. And the point of creating a healthy society, particularly a big city, was to separate out your drinking water from your waste removal systems, which seems obvious to us now, but it wasn't obvious to everyone back then. And they actually didn't have microscopes that were capable of seeing the bacteria in the water that was causing everyone to get sick. But they could, in a sense, see this presence indirectly in the data. So they could see, people who are getting their water from this place seem to be dying at unusually high rates, and people who are getting their water over here are not. And so there must be something in the water. But they did it by analyzing the numbers, basically, and kind of convinced the authorities in London to build the London sewer system, which was an incredible engineering achievement in that period, in order to basically keep the Thames free of all the human waste that was being kind of flushed into it. And, it's one of those things, again, that we don't appreciate because it literally is underground, right? It's by definition not visible. When you walk along the Thames in London today, along the embankments on both the north and south sides of it, those big embankments were built to house the main pipes that keep the waste from going into the Thames. And so you're kind of walking on that history, but again, it's very, it's not, there aren't monuments to it that are kind of visible, but it should be celebrated the way we celebrate a lot of those other achievements.
Wow. And now I've learned from your book that not only has modern sewage improved our collective health, but we're starting to use it to diagnose disease in our populations, which is an important part of the story, is seeing detecting disease as it emerges. I think we have a clip.
This is one of the largest wastewater treatment plants in California, handling the sewage of over 740,000 people. Eileen White is in charge of the facility, and she's at the forefront of trialing this new approach to tackling COVID-19.
When a person gets infected with the coronavirus, they may not feel symptoms for several days or a week. But when they're infected, whether they're symptomatic or asymptomatic, they're going to shred the virus in their poop. So when a person uses the bathroom at home, they flush, and all that sewage flows to this main wastewater treatment plant. So that sample then comes into our lab, and then our scientists in the lab put it into our PCR machine that can actually quantify the presence of the coronavirus in the sewage. So this can give the public health professionals a good week's advance notice of the presence of coronavirus in a region.
This is an incredible early warning system, revealing hotspots of coronavirus before people even have symptoms.
So I must say, Stephen, I think of your life hosting television shows as being pretty glamorous, parading through cities followed by camera crews, but sewage treatment facilities, how was that experience?
It was actually really easy because we were just talking to the people and filming the sewage treatment facilities. But for my last show on PBS, How We Got to Now, they forced me to go into a sewer pipe, sewer tunnel in San Francisco and kind of wade in there. And it was the worst thing I've ever done in my life. I mean, there was no redeeming, I wish I could erase it from my memory. It was so terrifying and disgusting. And so for this show, when they were like, hey, we should really do this sewage treatment plant in San Francisco, I was like, oh no, not again. But fortunately, they kept me out of the waste, as it were.
That is extraordinary, though, that we're now able to detect the emergence of viruses in populations through the sewage system.
Well, it's, the trick of this is it's all about getting ahead in the timeline of an outbreak, right? So people quietly start to get infected, and then they start showing up at their doctor's office, and they start showing up at hospitals, and then they start dying. And that, in the case of COVID, is about a 30-day timeline, right? And if there's a way the medical system begins to take note of the outbreak at that point when people show up at the clinic or the hospital, which is often, day 10 or day 12 or day 13 or something like that of the infection. And by that point, they've already spread it to a bunch of people. And so when you talk to epidemiologists and other public health people, they talk about kind of shifting the timeline of detection. That's the promise of this wastewater detection, is that you can see very small kind of trace levels of a virus in the sewage of a community and potentially get, 5 or 6 days of notice that you wouldn't have had otherwise, that there is an outbreak kind of brewing in the community, so that you can start to warn people or tell people to wear masks or tell people to stay home, whatever it is that you need to do. So it's a pretty interesting advance. And I think there's something kind of beautiful. There's a kind of a symmetry to it, which is that, it was sewage that was killing us in the 19th century. And now in the 21st century, it's giving us this, kind of clue that may help us stay alive.
We are clever animals, Homo sapiens, figuring all the stuff out.
Well, we also, created the systems that put all that human excrement in the drinking water as well. So we're not always quite as clever as we ought to be.
Yes, true that. Yeah, I do think sewage straight into the Thames was not so clever. One of the fascinating theories you return to throughout the book is what the Nobel Prize-winning economist Angus Deaton calls the Great Escape. Can you explain what that is?
In a sense, it's what we've been talking about. He talks about it as the great escape from, kind of mortality and hunger that took place kind of starting around 1800 and really spread around the world in the 20th century. And, seeing that epic transformation of life, really, nothing like that has ever happened before in our history.
Well, 3 innovations in the early 20th century that you write about that helped make the Great Escape possible were pasteurized milk, chlorinated drinking water, and seatbelts. Let's start with pasteurization. You quote from this thundering expose written by a journalist in the 1850s that reads, For the midnight assassin, we have the rope and the gallows. For the robber, the penitentiary. But for those who murder our children by the thousands, we have neither reprobation nor punishment. And I believe he's referring to the milkman.
Yeah, I mean, we think of milk as this emblem of, healthy living and vitality, like safe as milk is an expression, right? But particularly in big cities in the 19th century, it was a real killer. You didn't have mechanical refrigeration, and so you had spoilage. It could transmit tuberculosis from bovine tuberculosis that the cows had. And it was a major cause of early childhood mortality. Again, it's one of these things that we just, take for granted that milk is safe. But I think the story of how we made milk safe is a great case study in something we were talking about earlier, which is that it's not just about science. Most people listening to this are probably thinking, well, look, I know how we made milk safe. We did it with chemistry. I mean, it's literally written on every carton of milk in the grocery store. Pasteurization, pasteurized milk. Louis Pasteur figured out this technique for, heating milk up and sterilizing it, and that's how we did it. But in a way, the story of pasteurization is actually a story about the limits of science because Pasteur came up with the technique in 1865, but we didn't have pasteurized milk on our shelves as a standard in the United States until 1915. So it took 50 years for the idea to make a difference. And basically, it's because coming up with the idea is not sufficient. You need to get it into circulation. You need to convince people to drink it. You need to convince the dairy industry to do that. And that took a whole different set of actors. That took activists and legal reformers and muckraking journalists like the guy you were quoting. When you're trying to figure out how change this momentous happens, you need the brilliant scientists, you need the kind of white coats in the lab, but you also need people who can be evangelists for these ideas, who can get them, out into the real world.
So once we purified our milk, the next challenge was to purify our water, right? And the star of that story is chlorine, which I associate with swimming pools, which is a positive association for me. But an incredible story in the book is a story about how this guy named John Leal secretly added chlorine to the public reservoirs in New Jersey in the early 1900s. People thought he was criminally insane for good reason, right? I mean, it's like an act of terrorism, effectively. But this ended up being a real breakthrough, I think.
Yeah, Leal's a really interesting figure. We actually covered him in How We Got to Now as well as Extra Life because he's this great unsung hero. Chlorine turns out to be this thing that if you drink a glass of pure chlorine, you will have a very bad day. It is a poison. But in very small quantities, it turns out to be harmless to humans and lethal to bacteria that might be in the drinking water. So Leal had kind of come around to this idea that if you could put very small amounts of this, deadly poison into the drinking water, it would be overall healthier for people. And he just kind of did it. He didn't really ask for permission from the authorities or get, kind of public buy-in from the community. And so he was briefly in some kind of legal trouble for having done this, but it turned out to be an incredible intervention. And there's, there in that period in the United States between 1900 and 1930, that's where you see the biggest drop in childhood mortality. It goes from, somewhere around 30% to somewhere around 2% or something like that. And there's been some interesting studies where they can see when people start chlorinating their drinking water in different cities. And so there's a kind of natural experiment where you can see the impact of it. And people think that chlorination, along with pasteurization, were the two biggest impacts on reducing childhood mortality in that period. So this is a guy who's this kind of rogue idea ends up, being one of the two major factors that keep children alive during that period.
Extraordinary. Well, let's talk about seatbelts. I was gobsmacked, Stephen, by the story of John Stapp, the U.S. Army aeromedical researcher who in the 1940s and 50s strapped himself to a rocket-propelled sled on rails, accelerated up to several hundred miles per hour, and then decelerated in a matter of seconds, sometimes breaking ribs, suffering temporary vision loss, all to study the impact of rapid deceleration on the human body. And I guess the point of all this was that if you could decelerate from, I think, sometimes the speeds of over 500 miles an hour to zero in a few seconds without dying, surely we can figure out how to keep people safe in cars, which was not something the auto industry was thinking about, right? I mean, the assumption had been people die in cars. There's nothing we could do about it.
Yeah, there's photographs in the book of Stapp decelerating on the rocket sled. And it's kind of crazy because he's not wearing any protection. He's just like strapped to this thing going 500 miles an hour and then stopping in a split second. And, you see his whole face, kind of like everything that is movable on his face just kind of, continues traveling forwards while his body stops. And it looks like he ages like 30 years in half a second. So he was an incredibly heroic guy. And as you said, I mean, this is one of these situations where there were a set of technical solutions that had to be invented to make automobiles safer. The 3-point seatbelt being the most famous one, but airbags and anti-lock brakes and all these other things. But the first thing that you had to do was to convince people that a solution was even possible.
Yeah.
That was the in a way, the trickiest thing. And as you said, the automobile industry was just like, look, it's just physics. If people are going to drive at 50 miles an hour or 60 miles an hour and collide head on with another vehicle going the opposite direction at 60 miles an hour, you just can't survive that. I'm sorry. The human body just isn't going to be able to deal with that. And so there was a kind of just assumption that it was not a problem that could be solved. And then there were, again, these kind of interesting maverick outsiders, not inside the automobile industry, starting with this guy, Hugh DeHaven, who did all these famous experiments with egg drops that, a lot of high school physics class now do. And the idea was that if you could create the right packaging of the passengers, as DeHaven called it, that you could actually, the human body could survive this. And then Stapp got interested in it. It was partially interested in thinking about what would happen for pilots who were ejecting out of, high-speed planes as their bodies suddenly decelerated the second they left the plane and hit the wall of air that was going to hit them. But it was, Stapp recognized it was relevant to automobiles as well. And so, again, it was this work of persuasion, right? You had to persuade people that this was even something worth trying to solve. And then once you did that, people at Volvo began developing this idea of the 3-point seatbelt. Ralph Nader got, involved in the 60s, kind of arguing that, cars weren't as safe as they could be. And people began to think, well, maybe we should, just mandate that seatbelts be included in the car. They were optional, until the 60s. And then later on, you have mandatory, you have to actually buckle up and wear the seatbelt. And that process ends up saving a huge amount of lives. Like, automobile accidents were the number 3 killer in the United States in the 50s. And of course, now, you get in your car and you buckle up, you don't even think about it. But somebody had to fight for that innovation and dream it up and actually implement it and then pass the laws that made it mandatory. And that's an incredible part of our history as well.
And now our cars are avoiding collisions by themselves. Soon we may have driverless cars. And it's extraordinary to me that, I think it's today, 30 to 40,000 people die per year in the U.S. And at some point, that number might go down to a teeny fraction of that. And we just get used to whatever level of fatalities are presented as part of our existence. But potentially to our grandchildren, they will see even the level of risk that we face today in automobiles to be like the Wild West. Like how could you walk around with guns slapping on your thighs? Getting in saloon fights. I mean,
There's that classic scene in one of the early episodes in Mad Men. It's 1958, and Don Draper's wife is driving the kids around, and she's in her station wagon, and the kids are like, nobody's wearing a seatbelt, and the kids are just flopping back and forth between the front seat and the back seat. Nobody's in a, infant seat or anything like that. And she's smoking in the car. And you're just like, it's just one captures this kind of thing. Like, that was just a norm. And now you look at it, you're like, what were they thinking? That everything happening in that car is really, really bad for you. Why were they doing that? So yeah, we are capable of progress.
Coming up after the break, Stephen and I peer into the future. We managed to give ourselves an extra life over the last 100 years. Can we do it again in the next century? Hey folks, Rufus here. If you're a fan of our interviews with physicians, scientists, or entrepreneurs, then I have the perfect podcast recommendation for you, Raising Health. Previously called BioEats World, Raising Health comes from leading venture capital firm Andreessen Horowitz, A16Z. Each episode, Raising Health dives deep into the heart of healthcare, biotech, and AI with A16Z General Partners. Along the way, they explore the real challenges and opportunities in health and biotech entrepreneurship. Not to mention, you'll hear raw insights and actionable advice from notable guests like Omada CEO and co-founder Sean Duffy, and AI expert and In-Sitro CEO Daphne Kohler. Don't miss out. Follow Raising Health wherever you get your podcasts. Okay, let's get into my favorite topic, which is the possibility that new scientific discoveries may extend the upper limit of the human lifespan. This brings us to big idea number 3. We may be on the threshold of a more radical extension of life.
The extension of human life is our greatest achievement and our greatest threat. There's a strange paradox to the story of our extended human life expectancy. 100 years ago, when life expectancy was somewhere in the mid-30s, there were just under 2 billion people on the planet. Today, there are almost 8 billion. And that runaway population growth didn't come from people having more children. In fact, people are having fewer children per capita than ever. No, the growth in global population is the result of people not dying. Children living long enough to have their own children. Their parents living long enough to meet their great-grandkids. You do that for 100 years, and the generations stack up, allowing population to quadruple in a century. And as wonderful as all that life is, it creates its own set of problems for the planet. If we had just kept our population levels where they were in 1920, we wouldn't be facing the climate crisis we are today. There simply wouldn't be enough people on Earth emitting carbon into the atmosphere to make a meaningful difference in heating up the planet. And so, in a strange sense, we have climate change today because of 2 things. 1, industrialization, but also the triumph of public health and medicine. All of which raises the question of what comes next. We think using the existing approaches to treating illness, we can probably push average life expectancy into the 90s. But it's very hard to get far beyond that. The outer boundary of human life seems to be about 110. But a number of scientists believe that there's a radical paradigm shift in our near-term future, that we can treat aging itself as a kind of disease that can be cured, allowing us to push past that boundary and perhaps double life expectancy one more time. But if we start living to 150, the impact on population growth could be terrifying. So we need to decide as a species, not just can we cure aging, but do we really want to?
So, Stephen, you mentioned at the close of the book this possibility of a more radical extension of life. And there's been a lot of research on this topic. And a number of these researchers seem to think there's a very real chance of extending the human lifespan within our lifetimes by decades, quite possibly. What's your take on it?
Yeah, it's a fascinating question. And the science is really interesting, but maybe just as interesting are the societal and ethical implications of these kind of breakthroughs, which we can dive into. But first, let's just talk about the science. Most of us take it for granted that aging is this inevitability, death and taxes, like that there's something just inevitable about the decay of the body over time. And we've basically treated aging and ultimately death as an inevitability, as something that is just almost like a force of nature that we can't avoid. But what we've learned in the last 20 or 30 years is that the aging process seems to be something that is, in a sense, kind of programmed into our bodies by our genes. And if you look at other organisms, probably the most interesting case study of this are bristlecone pines, which are, depending on how you measure it, the oldest organisms on the earth, or, can live for 5,000 years. And people have analyzed the kind of cellular structure of bristlecone pines, and they've found that on a cellular level, there is no difference between a 40-year-old bristlecone pine and a 2,000-year-old bristlecone pine. So it is basically programmed on some level to never age. And that's because human beings basically are constantly repairing themselves, right? Our cells are constantly repairing themselves. Our immune systems are constantly fighting off cancers and runaway growths and other problems and other genetic mutations that happen. And there's a certain point at which our bodies basically stop that repair or get worse and worse at it. And the idea is that as we understand more about how the genome works, as we understand more about how the immune system works, we might be able to, in a sense, alter the programming and say, you know what, that point when you reach 40 or 45, when your body starts getting worse and worse at repairing rogue cells or genetic mutations, let's actually keep that repair process going. And there are a lot of different kind of interventions that you could make to do that. And none of this has actually been fully proven yet, but there is a reasonable path to taking that state you're in when you are 25 or 30, where basically you don't age between the ages of, kind of 25 and 35. Your body basically just stays, it stopped developing, but it hasn't started aging yet. And the idea is that you could basically take that period of your life, the prime of your life, and extend it indefinitely, which would have two effects. One would be you would live in that state for a much longer period of time. So you would have a much longer health span where you're basically in full command of your faculties and, you're healthy and you're not aging. And that would be great. I think we all agree we would like to extend health span. The question is, could you also then extend lifespan radically past that, barrier that I was talking about of 110 or 115? And could you actually have people who live into their 150s or beyond? That's what's on the table. And I think the thing that, we have to confront on some level is that this is no longer the realm of snake oil salesmen and imposters. I mean, there's real science that is suggesting that this is possible. And so we're going to have to grapple with this question potentially in the next 10 or 20 years. Like, do we want to do this? And what would it mean if we actually did do that?
I just finished this book by David Sinclair, who's one of the heavyweight researchers in the category, called Lifespan. And he describes exactly what you've just described, this erosion of the cellular repair mechanism of our cells, and references a number of things we can do about that. Fasting, as you know, Stephen, I've been intermittent fasting for some years now, so I've taken an interest in this. Exercise is helps with cellular repair. Oddly, being cold for sustained periods of time seems to be helpful there. But there are also these, people are talking about this, resveratrol and NAD boosters and metformin, different compounds that may or may not help with cellular repair that some of these researchers are themselves taking. But when I've mentioned this to people, the most common responses are, number one, this can't be true. This sounds like baloney. And the second, I don't want to live past 90 because I think most people picture in their minds this sort of extending the final years of life, which sounds dreadful. As you point out, that's not really what these researchers are talking about. But then the key questions become, what would the consequences of extending the human lifespan be for us, both as individuals and as a society? What are the implications, and how should we think about it? Should we be discussing whether or not this is a good idea?
Well, I think there's no question we should be discussing whether or not it's a good idea. And that's part of the reason why I brought it up at the end of Extra Life is that, we are on the precipice of arguably the most significant scientific, medical, technological breakthrough in our history. If we could actually, in a sense, treat aging as a disease, not as an inevitability, and actually cure it, that would change everything. Right? That would be the most momentous thing that we'd ever done. I mean, I already think that the extension of life over the last 100 years is momentous. But if you really made death optional, it would be, an order of magnitude bigger in terms of its impact and its consequences. And so I think we should be having the conversation. Why not have the conversation now? Here are the potential problems. One, you would inevitably have a significant period of time where these treatments would be incredibly expensive. Just at this period where we're reducing health inequalities, we would suddenly see a massive gap opening up. Literally, we would have a caste of immortals and who can afford these treatments, and then the rest of us who just die like commoners. And that's challenging to think about. Presumably, over time, that would go away as these treatments become cheaper. That is just the way of the world. And so immortality would be something we would slowly offer to the rest of the world. But that sure seems like a pretty intense thing to opt into as a society. Let, the rich people live forever and the rest of us not. Secondly, we know that one of the, major consequences, as we've talked about, of the extension of human life expectancy is population growth, right? We went from 2 to 8 billion people because people started living longer. If people just stopped dying, that process, which we think is right now about to stabilize, we think that population growth is probably going to plateau sometime in the middle of this century, and we won't have this runaway population growth problem. But if people stop dying, it'll be right back on the table. And so it raises issues about the kind of carrying capacity of the planet and whether we could support 10 billion people or 12 billion people, which is what might happen if people started living longer. Those are the kind of big, I think, ethical challenges. The positive side, besides, reducing death in human populations, which is generally considered to be a positive, is an extension of what has already happened over the last century, which is intergenerational connection, right? I mean, my children got to know their great-grandmother who lived to 104. They had meaningful relationships with their great-grandmother, and if we could move to a society where you would have those kinds of connections to your, distant ancestors, your great-great-great-grandparents. There is something, I think, incredibly beautiful about that, and perhaps it would force us as a species to have more of a long-term perspective if we thought we were going to be around in 2100 and that our kids might be around in 2200. And so it might widen the or lengthen the temporal horizon for those of us who are here now, thinking that we might live that long. I think that would be a lovely side effect of this.
Well, that gets into the political implications of extending the human lifespan. And you pointed out that if our age demographics looked as they did 100 years earlier, Donald Trump probably would not have been elected. There's this view that we need older generations to die off to allow societies to evolve and progress. On the other hand, as you just pointed out, there's an argument that we all suffer from short-term thinking, and that maybe people not caring about the environment or maybe not caring about the long-term implications of economic policies or what have you, it's easy to have those perspectives if you only have 10 years of life left. But if all of a sudden people that we consider old today have 50, 80, 100 years left, it could encourage a more kind of wise long-term view of how we think about policy and operating as a society.
Yeah, I think that's the really interesting question. Is like, what would happen? The whole meaning of what it is to be old would change, right? And so on the political side, you were referencing this thing that I kind of did, which is back of the envelope calculations. Yeah. But basically, right now the electorate gets much more conservative as it ages. And so if you look, Trump support and also Brexit support was predominantly, it was overwhelmingly from older people, and the younger folks were, anti-Brexit and anti-Trump. And because the overall composition of the electorate has gotten older, the graying of the electoral vote, that's, of course, because people are living longer. And so it has skewed the overall kind of tallies towards these more conservative positions. But I think the question, and you're kind of raising this in a way, is if those 75-year-olds or 80-year-olds who were voting in this very conservative way were not biologically 80 years old anymore, they were 35 and they were still working and they were still active. Like, is there something about of being a traditional old person that makes you see the world in that way? But if you are actually biologically still a young person in the prime of your life, do your politics actually change? We genuinely don't know the answer to that, but it's possible that, you would see a fundamental kind of reconfiguration of what it means to be 80 or 90, just as, we witnessed, as we discussed, a fundamental redefinition of what it meant to be a child, right? We've gone through this kind of change in the past where being a child 150 years ago was the most dangerous, most deadly, most terrifying time of your life in terms of health threats until you got to be very old. Now that's not the case. And so we reinvented childhood, and that had all these different implications. And so there's a chance that we would see something similar happen with, centenarians, people living into their hundreds.
Well, how would you propose, Stephen, that we wrestle with these issues? Where does all this land?
Well, I think back to a conversation that you had on this podcast with Walter Isaacson talking about CRISPR, right? Isaacson talks a lot about gene editing and, that point in the not so distant future where we will potentially be able to technically to edit the genes of our future children and select out certainly dangerous, deadly mutations, but it then raises the possibility of, well, I would also like them to be a little taller. And why not give them, better math aptitude or whatever, who knows what we'll be able to do. So, you have these enormous ethical quandaries that are raised by these new developments. Should we allow people to edit their children's genes? Should we, cure death and allow people to live forever, that are rapidly kind of approaching potentially? And the problem is we don't really have a mechanism as a species to decide whether we want to do these things and decide what the limits are and decide, where to put in the kind of guideposts or where to say no. And, that is a complicated process, right? Because we're talking on, kind of planetary level decisions about reining in technologies. And we historically have not been very good at that. But there are lots of things that historically we weren't good at that we ultimately were able to figure out. You think about something like the eradication of smallpox, right? It was both scientifically, but also institutionally impossible to eradicate smallpox 250 years ago, right? We didn't have smallpox vaccines, but we also didn't have organizations like the WHO that could organize a smallpox eradication effort all around the world, that could put field workers on the ground to vaccinate people in all these different places. So we didn't have the institutional capacity to do something as bold as that. And then we figured out how to do that, and we invented institutions like the WHO. And so what I've come to believe is that we need a comparable level of innovation on the level of kind of governing bodies or ethical oversight systems that can help us wrestle with these kinds of questions and help us decide collectively whether we want to do things like cure death. And that has to involve all of us, right? Right now, it's just up to, the scientists in labs and the Silicon Valley people who are funding this research and evangelizing for it. And it can't be just up to them, because the stakes are so high, the consequences of something like this are so immense. We all have to be involved in this kind of collective decision. And so, once again, the innovation that we need, that is really kind of urgently needed, I think, over the next decade or so, is not just some new pill, it's not just some new vaccine, it's actually a way of, as a society, collectively making decisions like that. We need to invent that kind of system as much as we need to invent some new radical cure.
I think it's going to be difficult for people to resist this should this technology actually emerge. But I completely agree that we're going to need to all collaborate to make intelligent, far-sighted decisions around these new technologies.
Yeah, I mean, I think it's, you can look at it on one hand and say, wow, look how bad we are at coordinating globally in terms of climate change. But on the other hand, we're far better at coordinating globally than we were a couple hundred years ago on lots of fronts. So we've actually made a huge amount of progress. We just are facing complex challenges like climate change that we haven't, faced before. And so we're not very good at them yet. But we have a great track record over the last couple hundred years of solving these big, seemingly intractable problems. So, that's where I'm, in a weird way, I'm kind of an optimist, but I'm an optimist in the sense that I think that it's important to recognize what the real threats are and just be optimistic about our ability to solve them.
Well, Stephen, thank you for your optimism. We need it. And thank you for your fascinating book, Extra Life, and for your time today. It's such an interesting conversation.
It's always great to talk with you, Rufus.
Would you like to hear what Stephen thinks are the 5 biggest ideas from Extra Life? Download the Next Big Idea app and check out his book bite. And why stop there? In our app, you'll also find a fascinating video e-course based on another one of Stephen's books, Farsighted, as well as a riveting conversation he had with our curator, Malcolm Gladwell. Search for Next Big Idea in your app store right now. If you like this show, please tell your grandparents, your great-grandparents, and your great-great-grandparents. And if you have a chance, leave us a review and a 5-star rating if you think we've earned it. And if you don't think we've earned it, tell me why. You can shoot me an email at Rufus, R-U-F-U-S, at nextbigideaclub.com. Special thanks to my friend, Stephen Johnson. Look forward to living to 150 with you, buddy. This episode was written and produced by Caleb Bissinger. Our executive producer is Michael Kovnat. Theme music by Costa Galanopoulos. Sound design by Jason Freeman. I'm your host, Rufus Griscom. See you next week.